In this video clip, we learn how to find the autocorrelation coefficient and test its significance using Minitab. We are using our data file, example 3.1. We double-click to open it in Minitab. We can enlarge it. Here we study column YT. We go to Stat, Time Series, Autocorrelation. We click it. Series, we use C1 YT. Double click. Default number of legs is 1/4 the number of records, which is 3 in our case. We can specify the number if we want different number. For example, we can use 6 here. We can choose to store ACF, store T statistics, store LBQ statistics. If we check them, then the results will be stored in this spreadsheet file. Then we click OK. You see in the spreadsheet, the results are stored as we have specified. We can see the results clearly from the output here. ACF shows the autocorrelation coefficient as a function of lag, so we call it autocorrelation function. We can see the values are depicted using vertical bars here, 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 and so on. Okay, now we see these t-test statistics, column T. They are used to test the significance of each individual autocorrelation coefficient at a specific lag. For example, regarding lag 2 autocorrelation coefficient, we have a t-test statistic 1.25. We can test the significance by comparing the t value with the t-test critical value. Here, the t-test critical value can be found using a t distribution with degree of freedom as the sample size n-1. We can find the critical value, for example, assuming the level of significance alpha is 0.05. We can use Excel to find the t-test critical value. Here we can use Excel formula T dot inverse. The first value is probability, cumulative probability. The t-test is a two-tail test where we have critical regions on both ends. So here we use a positive cumulative probability 1 minus alpha over 2. Here we assume alpha is 0.05. The second parameter, degree of freedom, is the number of records minus 1. 11 in our case. So we find the t-test critical value is 2.2 roughly. We go back, we can see the t value is less than the t-test critical value at alpha equals 0.05. So we say with significance level 0.05, we have no evidence that lag 2 autocorrelation coefficient is significantly different from 0. Further, we can see two red lines in the ACF chart. This specifies the confidence interval estimates using confidence level 95%. So essentially, if we use alpha equals 0.05, then if the coefficients do not reach the two lines, we can say that the coefficient is insignificant as comparing with 0 at alpha equals 0.05. Here we have tested each individual autocorrelation coefficient. Now we can consider coefficients as a group. For example, if we consider legs 1, 2, 3's coefficients as a group to test whether they jointly different from 0 or not, we can use the LBQ statistic. Here we have 8.82. Here we compare this LBQ statistic with a critical value found using an chi-square distribution with degree of freedom, the number of legs in the group, which is 3 in our case. So again, we use Excel to find critical value following chi-square distribution. We can use Excel formula chi-square inverse. Probability, here be careful, we still use alpha equals 0.05, but the region of rejection is only on the right end. Here the cumulative probability is 1 minus alpha. Degree of freedom is the number of legs. Here we have 3 in our test. So we find the critical value 7.8. Then we compare 8.59 with 7.8. We can see, we should use 8.82. We can see 8.82 is greater than 7.8. So we say that at alpha equals 0.05, we have evidence that the first 3 autocorrelation coefficients at legs 1, 2, 3 is different than the site of 0, 0, 0. We can see here the results from t-test and the chi-square test is different. That is because we are testing different things. In the first case, we are testing the significance of the individual leg 2 autocorrelation coefficient. In the second case, we are testing the coefficients altogether for legs 1, 2, and 3 to see whether they are different jointly from the site of 3 zeros.